Hello, everyone. Welcome back. I'm Steve.
And I'm Scott.
And together we're Backyard Musings broadcasting live Apple Valley, California.
Yep, that's Science and Technology Channel.
Yes, sir. Yes, sir. We are not the experts.
We are not.
We are the messengers.
And we're told that every day.
Yes.
By the people that love us.
Humblingly, yeah.
Yeah.
Venus may not have Earth-style tectonic plates, but it's far from geologically quiet. A new model shows its crust is surprisingly thin and undergoes dramatic transformations, breaking off or melting into the mantle. Now that's wild. Like parts of lands breaking off and melting into the mantle? That is wild. And potentially triggering volcanic eruptions. This crustal metamorphism gives scientists a whole new perspective on how Venus churns beneath its blistering surface. Upcoming now, when you look up there with the your binoculars, or you'll see that it's like doing this little roiling and broiling thing.
Yeah, I've never done that, but there's some interesting words of description here, right? Churns and melting and thing you don't normally think about in a planet. Especially that close to that close to the sun. Maybe that's what the melting part comes from. So because they're closer to the sun than we are. So anyway.
Upcoming missions like DAVINCI and VERITAS aim to find out just how alive the planet still is. Would you like to know more?
Venus, often called Earth's hotter twin, which I was telling Steve, I had no idea that was the case.
Yeah.
Never heard that before. May have a much more dynamic crust than scientists once thought. New NASA-funded research reveals surprising activity beneath the surface of this scorching planet, shedding light on how Venus might be reshaping itself from the inside out. For a long time, scientists believed that Venus's outer crust simply kept getting thicker over time. Since the planet doesn't have the kind of plate tectonics we see on Earth, there didn't seem to be a way for crust to return to the interior.
But a new study published in Nature Communications suggests something different is happening. Instead of just piling up, parts of Venus's crust may be breaking off or melting due to pressure and density changes deep below the surface. This process is known as metamorphism, and it may be key to understanding how Venus stays geologically active.
On Earth, the crust is broken into large moving plates that interact at their boundaries. These slow but powerful movements form mountains, trenches, and earthquakes in a process called plate tectonics. When two plates collide, the denser one can be pushed down into the mantle below in a process called subduction. As that plate sinks, the increasing heat and pressure change the rocks in a transformation known as metamorphism. This not only alters the crust, but also plays a major role in driving volcanic activity.
It just reminded me, metamorphic rock. Igneous, metamorphic. Yeah. Okay. That makes sense now. In contrast, Venus has a crust that is all one piece, with no evidence for subduction caused by plate tectonics like on Earth, explained Justin Filiberto, Deputy Chief of NASA's Astromaterials Research and Exploration Science Division at NASA's Johnson Space Center in Houston, and a co-author on the paper. The paper used modeling. Okay. I don't quite like modeling.
Yeah, well,
because there's variables that go into it,
They throw in whatever
and you can make it with the computer model. You can tweak it just a little to do whatever you want it to do. The paper used modeling to determine that its crust is about 25 miles thick on average, and at most 40 miles thick.
Quote, that is surprisingly thin given the conditions on the planet, said Filiberto. It turns out that, according to our models, as the crust grows thicker, the bottom of it becomes so dense that it either breaks off and becomes part of the mantle or gets hot enough to melt. So when Venus has no moving plates, its crust does experience metamorphism. This finding is an important step toward understanding geological processes and evolution of the planet. So I wonder why there's never been a push to go to Venus.
Probably because the atmosphere is
too hot there, maybe?
Too hot too, but how do you get through that atmosphere and then get someone out? Or are you talking about an orbital collection?
Either that or just trying to, land there, put some kind of like a surveyor type landing craft on there where you can,
robotic
soil samples and But anyway,
I think that's what DaVinci is doing.
yeah,
Veritas.
yeah, maybe so.
I was going to say something. So what I should have did and I didn't. I should have got a cross section of the Earth that shows, where the mantle, the core,
the inner,
so that we could compare how thick is the crust here, how thick is the mantle here, so we could compare it to Venus. But I didn't do that. Steve. All right. Quote. This breaking off or melting can put water and elements back into the planet's interior and help drive volcanic activity, added Filiberto. This gives us a new model for how material returns to the interior of the planet and another way to make lava and spur volcanic eruptions. It resets the playing field for how the geology, crust, and atmosphere on Venus work together.
The next step, he added, is to gather direct data from Venus's crust to test and refine these models. Several upcoming missions, including NASA's DAVINCI, which is Deep's atmosphere, Venus investigation of noble gases, chemistry and imaging, and
DAVINCI.
VERITAS, which is Venus emissivity, radioscience, INSAR, topography, and spectroscopy.
Say that 3 times, yes.
I'd rather say VERITAS. And in partnership with ESA, which is the European Space Agency, Envision aimed to study the planet's surface and atmosphere in greater detail. These efforts could help confirm whether processes like metamorphism and recycling are actively shaping the Venusian crust today and reveal how such activity may be tied to volcanic and atmospheric evolution.
Yeah, that's interesting how they say recycling the crust. That's, breaks off and melts and
then
interesting
forms again and then does it again. Yeah.
DaVinci will send a meter diameter probe to brave the high temperatures and pressures near Venus's surface to explore the atmosphere from above the clouds to near the surface of a terrain that may have been a past continent. During its final kilometers of free-fall descent, the probe will capture spectacular images and chemistry measurements of the deepest atmosphere on Venus for the first time. That sounds exciting.
Yeah,
I'd like to see that data.
I can hear a miner on Venus now.
No, that's...
Yeah. Oh, no, that's Cameron.
That's Cameron.
It's mining on his slide. So, okay.
All right, folks.
That's a good one.
Thanks for joining us.
Take care, everyone. Have a good day.
And enjoy your Sabbath.